137, single numbers 2. Given a non-empty array of integers, every element appears 3 times except for 1, which appears exactly once. Find that single one. Your algorithm should have a linear time complexity. Could you implement it without using extra memory? I mean, in general, I don't like these kind of problems for that reason. But let's see. Yeah, is this some kind of crazy XOR thing again? A lot of people like this one though, but that's maybe because they have a clever E solution, which I about. Uh, hmm. Let's see. What does it mean for a number to appear 3 times? Well, 2 of them cancel out, but and I'm obviously trying to do it with in all of one extra space. Yeah, I have the sense that it's going to be some clever XOR thing, but let me see if I can figure it out first. But yeah, I mean, I just want to get. I mean, I, these are the type of. So when earlier today I was talking about like back in the day you would see clever program brain teaser stuff. These are the type of problems that I think like 10 years ago you would get on interviews sometimes as a result. I think nowadays people are slightly get at least in the trendy part of Silicon Valley type things. So I don't know if like because we were talking about Midwest and other places, so they might still use point teaser things. Uh, but like so 10 years ago, like definitely is something that even in New York you see a lot of these point teaser things where like oh yeah just do some XOR trick. But I feel like it's less and less because it seems I don't know. But yeah, I feel like these kind of problems are like not really useful per se, like XOR tricks. I mean, it's fun as brain teasers, but I don't know if it's super useful at all. I mean, I guess you could make the argument for even dynamic programming problems. So maybe that's a judgment or whatever. But okay, so I've been kind of rambling, but so you can't just XOR everything, really. Uh, I don't even have a great thought process as I'm getting through this, to be honest, a little bit. I'm just like, my first thought is just XORing everything or in some way to partition the XORs, um, which is not super useful. I mean, if you XOR everything, then two of them would cancel out, but um, you still have essentially the entire list XORed, which is not super useful, maybe. Um, hmm. Oh yeah, I forgot the quote unquote the naive solution that if I'm an interview I would bring out first of all is that you just put everything in a hash table, etc. I mean I don't think I have to describe that solution too much, but well, but I just want to point out that on an interview I would definitely still point it out because as an interviewer I don't assume people even know about hash tables because there are people who don't, to be frank. As an interviewee, like I would point it out just to kind of make it clear that I know that that's a thing, but obviously it takes off n space and so like and also it would make the problem trivial and so forth. But yeah, uh, but I would still point it out just in case. Yeah, I mean I think people have gotten better over time, at least at like phone screens and stuff like this. But I think like in general, a good amount of people, and if you know hash table solution, then like you're already ahead of a lot of people. I mean, it's not sufficient to do well in an interview. Like you need a lot more than that. But there are a lot of people who do not, just to be frank. So it is what it is, which is you know. But okay, I mean this is like the type of problem that PB Action was talking about maybe earlier, where like it's so binary, where like I'm just like running through a lot of scenarios in my head. I don't like where I'm running through them and then I'm tossing them away without even So it's just me not even talking about it because it's so weird. But linear time means you can only go through the same array like X amount of time. Extra memory, which is kind of weird, but uh, mm, Is there a way to? Yeah, definitely. Yeah, I think what I think about when so one thing that I would mention is that linear time does buy you some hints. So there are a lot of in the sense that there are a lot of restrictions on what you can do, right? And what that means is that well, like one meta algorithm, if you want to call it that, is just like multiple pass through the array in some way, which in general requires additional memory, whether it's constant or because if you do multiple pass and you don't do anything, then like I think well, I also like I think like the extra memory is also a little weird. Uh, yeah, right. But I think the extra memory also like phrasing is a little particular. Like I wonder if you could like edit stuff in place because if that's the case, then like maybe that's a I don't know a hack. But like for me, that's still I don't know that's like a low level optimization, but not like I don't know not I don't like it in general. I guess is what I'm trying to say. So but yeah, so yeah, the first, one of those is O of n is just going through the list multiple pass. Another way to get O of n is having two or I guess in theory multiple pointers where like you have a window fingery algorithm where you're scanning it that way. Um, but and then yeah, and then you kind of because you're doing that, it's O of n because you're basically doing a full like a pass but concurrently with some like offset. That's also O of n time. So those are the two things that I'm thinking about. How to use that is another story, obviously. Um, and I think I want to ask for a hint, and only in the sense that uh, um, in a sense that I don't know if they like I don't want to waste so much time to find out that the extra memory means that we just store stuff in place in the input array. Because if that's the case, like that's somewhat cheating. I mean, not I don't know if you describe it cheating or whatever, but then like because you could do that in place or not in place with another way. Would you call it O of n memory or I don't like it's O of one extra memory, but it's still O of n memory. I want to say, like it's the size of the input. I don't know. Can someone? um, so that's the question I would ask because if that's the case, that changes a lot of things like that we could play around. Because I generally don't like. Yeah, I mean, I know it's a hint, and that's what I would kind of like. But it's both a hint and a clarification. I feel like if I was in an interview, then it's what I would ask. To be frank, I'm like, hey, can I modify things in place? Because sometimes that's a restriction, and in general, I prefer not because I don't know, like I'm is more functional, I guess. Um, but like that changes things because essentially then you know like you're doing O of n space anyway because maybe you have to be clever on like certain things, but yeah, I don't know. Uh, well, I think that if we could figure out a way, no, I mean, if we could modify it in place, I think I have an O of n algorithm. Um, wait, is that true? Yeah, if we could modify things in place, I have an O of n algorithm, I think. Uh, maybe. No, maybe that's not true. Let me think about this for a second. I was thinking of some like two-pointer thing, but maybe that's not true. Maybe I lied. uh, so one thing that I would think about is like maybe some kind of running XOR type thing. What a weirdish file. Because uh, now you get to see me struggle. Damn, you're supposed to rat. Hmm. Well, the zero is also a little tricky to handle as an edge case, possibly. I might have to think about it. But Man, hmm. Yeah, it's also well. I was also saying like it's even worse than algorithm problems. It's almost it's binary, so maybe I guess it has more relevance than the other one with the mathy one. But yeah, I would say as a no spoiler alert, I also did the similar thing with single number three, where I essentially like played around with it and then essentially some guessed at an answer and then kind of got it. So I'm afraid that it'll probably end up this way. So I don't know how much explanation I could do before I get the answer. Like there's no linear path to the answer, which is kind of a little annoying to make progress on. And also, this is even worse than the other one in the sense that like once you get it, you probably get it. It's like a like exactly like a brain teaser, right? There's once you know it, you don't, you know. But can you do a running XOR? What does it mean? Hmm. No, that doesn't make sense. Okay. Uh, well, if you do an XOR, you essentially cancel. So you have one element, but you need to know that is more than one. Huh. Now I'm trying to think about like what does it mean at the end result? No, well, it's just a XOR of all the numbers. So, because so this is like similar to what my current thought process is just similar to what I was trying to do with single numbers three, um, and see if I could learn something from that. But like maybe not, because in that problem you take a bit and try to figure out that way. Uh, okay, I'm gonna for now assume that you can do some in place editing of the input away. So what does that change for me? Mm, hmm. Well, what? And you can't do it twice to cancel things out. Or rather, it'll also cancel out the number you're looking for. Hmm. Man, hate this problem. uh, that's okay. Well, let's look for the examples. Maybe, maybe I could figure out that way a little bit. Uh, let's grind through this a little bit. So you have 2, 2, 3, 2. So in binary, it's 10, 10, 10, and 11. How do you? So the XOR is 0, 1, right? Yeah. Is it Gremlin XOR? Am I? It's just like one of those. What is it? Red herrings. Um, but and we do. So these two could. Oops. So these two could cancel out. Mm, what does it mean? Hmm. Okay. Oh, that doesn't make sense. Maybe. Well, I think for I would say if this is the case, if this is a binary problem, I think the one thing that you could try to think about is just in terms of bits. Well, I mean that's what I'm doing, but I mean like one bit at a time. Um, and what, and what I was trying to think is what does this mean? Well, so what does a zero mean in this case? Because and this may not apply to the more general case. Um, I'm glad can. I'm glad I could, I could show some empathy to your situation. But yeah, this might not be general, but so maybe it's something. But for it to be zero, that means hmm, doesn't mean that doesn't necessarily mean much, maybe, because if I do something like that, and that these cancels out, and we still have the same x, then we add like say the number one, then you have this. Hmm. Yeah, I think one thing that hmm, yeah, maybe one strategy I would think about, and it's something that we talked about earlier with, uh, is that maybe I would try to do something that's not linear, and then see if we could kind of optimize it to be linear. Um, but I want to do it without extra space. Um, okay. So if we, is there an O of n square algorithm? Yeah, there's a trivial n square algorithm where you just kind of go through it, see if it even appears twice. That's all you need. Um, and you checked it for each element, right? Okay. So is that? Well, so at least I would point that out, I guess. But is there a way to generalize it? Man, a lot of the stream for this problem is just going to be me with a perplexed face. Oh, this is only a medium too. I guess this is what it is. I feel like also for a lot of these problems, people have seen it before, so they just go like, "Oh, it's just this," which is maybe fine. But, hmm. The only other thing I would think about that's not related to bits is some numbers relating to the sum of the numbers, maybe. But yeah, yeah. For now, I'm okay with you know just thinking about one extra number. I mean, so I'm just reading the chat. Yeah, and I hope that I mean, sometimes you, like I was saying earlier, sometimes you just get unlucky, and that's part of the luck. Is that you know? But is there? Hmm, Does knowing the sum of the array buy me anything? I mean, in these examples it does, but not like in the general case. Well, yeah. Well, something like that. I'm just thinking about the sum situation. Can we do something with sum? You add them and you have a sum, and then you maybe not. Because you still try to figure out like the odd number out, but the odd numbers of the other ones. And there's no easy way to change the parity of that thing. Why do people like this problem so much? I guess when you see it and huh. Well, I would say if I'm interviewing, I hope I don't get this problem. Though maybe after this, I will just remember the answer and. But I'm glad I did not see this before interviewing or whatever, or the other way around, interviewing before seeing this. But in terms of XOR, all these doubles cancel out, so I don't know how that buys me anything. I need to figure out a way to subtract two of these. There's no Oh. Really? Sorry now, too. Maybe I might have I might have misinterpreted what you meant by the general version of this poem. Oh, k times? Is that the? Huh. No, I don't think I've solved that. Well, if k is even, I think it's trivial, right? But if k is odd, which is like in this case, which is half the problems, I guess, then well, that's what I'm trying to figure it out. So I think for k is even, like the XOR trick works, is why it's trivial. If x is odd, then or if k is odd, sorry, yeah, then we have this problem, which I think is the same as, if I think like they're all the same if k is odd, but maybe the XOR is just red herring, and I'm like spending ridiculous amount of time in it. But I mean, it's either that or I mean, it's either sum or XOR, right? I feel like in some weird way, because like, what else can you do in linear time? I mean, it's either maybe some kind of something. And you can't really like double some of the stuff without. Oh yeah, I mean, and I think really kind of talked about what you might call it, but using a hash table, but and yeah, I mean, and I guess Leetcode per se cannot really, uh, you know, they can check to see if you haven't used extra memory other than complaining about it, or like you get a bad percentile or whatever. So I mean, but like but man, this gives. I mean, this answer gives me an XOR of 01, which is what we talked about earlier. But that doesn't tell me anything, right? Because that's just the same as this, right? So I don't know if I could, at least it has to be some really clever way. Because these two problems, maybe that's at least an insight. These two problems have the same XOR, right? So how do I differentiate between them? Well, let's play around the sum, maybe. So let's just do this. 9 equals 11. Oh yeah, I also agree with that because I think you could reduce the case. You go to odd case to this, and then that's standard-ish maybe. I mean, we'll see. But and k equals even is also. I mean, we already talked about it a couple of times. So, um, what's that? 15. What does that mean? Well, how do we do this in a good way? Well, we can't get to this easily. So can we take advantage of some weird? What does the 9 tell you? Well, what does the 9 tell you when you see a 2? Like, let's say you subtract this. Does it really tell you anything about the rest of the suffix? Oh, sorry. And store the result for the next XOR. What should we mean by that? I mean, I was thinking of something like a progress thing. Yeah, I mean, I would definitely start like just hacking on random stuff, for sure. If there's an interview, maybe I'll just do the n square one, but then like try to figure it out a little bit more. Uh, can we do this bit by bit? Can we even figure out what the bit of the final answer is? Because we can then, like you said, we could do some order width times n thing. Um, like in this example, both of them have the same bitwise thing, right? And there's no easy way to differentiate between these two. Well, do you know that the answer is 1? Or worse, on the 1 bit, the XOR of these two are the same. So there's no way to differentiate the last bit is 0 or 1. Is there? Well, maybe you could count. No, can you? Well, in this case you can, but maybe not generally. No, well, can you? I guess you can. Maybe that's it. But no, I think you gave me a great idea. But yeah, oh, okay, yeah, exactly. No, no, no. I think that's exactly what. Yeah, I think you gave me the idea of the width times n, and I think just counting the number of. I mean, I don't know what I mean by extra. Maybe I mean because all of one extra memory or like literally one integer, right? And just do it bit by bit. Is that considered cheating? I don't know. Or like that's is that good enough? Like literally one variable, but that's how you would do it. Yeah. That I mean, I don't know if you consider like we arrived at essentially the same time where you said all width times n, but yeah, yeah, because it's either there's one bit left over. Yeah, yeah, yeah. I mean, divisible by three essentially. Sorry. Yeah. I mean that solves the problem, but it's all one space. Okay, well, and that's better than nothing at least. Um, but I think similar to, oh man, maybe that's. I mean, what you said it's also true, but now it actually. What now I want to think about maybe not XOR, but instead of looking at things in a binary, maybe we could look at it in trinary, ternary. Because then in that case, yeah, because in that case, in ternary, you sum up all the things in that base or in that digit in the ternary representation. We're saying the same thing roughly, maybe. Um, and then the mod of that is the answer for that digit, I think. Um, wait, is that obvious? If it's sum divided by 3? But no, I think I have the right answer though. That will be funky. Or like working for, I mean, it does take all of one extra memory, which is like one variable. I think you just count the, yeah, because, okay. So you look at a base, right? Let's say you have base k, which is in this case 3 actually, not k. But you have base 3, then because something appears 3 times, it'll always be divided by 3 except for the number that's left over for that digit, right? So I think in that case, I mean, I think that's the answer, which I think Nell 2 was talking about. And I think we came in at exactly the same time, roughly. I'm going to stand by. Maybe you did a little bit earlier, but I didn't look at the chat at that exact instance. But I think you're right, which is that, like, okay, let's look at all these at base 3. The sum divided by 3. Maybe I'm not understanding that particular piece. The sum divided by 3, so 9. So I have this sum, right? And this. So what does that mean? Remainder 2. Mm. Not sure, but I mean, sorry. Yeah, PB action. I'll get back to you in a second. I think. I mean, I think I have a working solution, at least all of one solution, which is that. Okay, well, let's look at the last digit, right? Which is last digit of a base 3 number. Um, I mean, I don't know if that's going to work, but we could. I mean, I have a working solution now, I think, which is you look. So every, yeah, we'll go through it. I just want to, because I have a working solution, I want to get this out, and then we'll explore that answer in a bit. Is that okay? I just don't want to like half focus on two different possible solutions. Maybe, I mean, a lot of these farms have multiple solutions, probably, to be honest. So, but yeah, 'cause I don't know. But if you look at but let's say you do take a mod 3, which is the last digit of the number, then you sum it all up on digit by digit. Maybe that's what you meant. I may have misinterpreted. But we sum that all up. That digit is the first digit on the base 3 of the result. I think that's probably right because if it appears n times, or sorry, if that digit, because if every number on a base 3 shows up 3 times, then by definition the sum of all those digits would be 0, right? Mod 3, except for the number that appear only once. So that's what I think I'm going to do. Just a base 3. Yeah, so that's with times okay. I mean, it's all one extra space, which I think is made. I don't know. It depends on what they mean by extra memory. Maybe we could put it somewhere, but but it's at least we have an all of one extra space solution, right? Um, yeah, I mean, it's that. Now I'm super convinced this works. I don't know if this is extra memory, quote unquote, but yeah, maybe I'll let y'all work on that other possible path while I do this. Um, okay. Uh, how do I do this in a clean way though? Because then you have to like. Okay. Yeah. Let me work on my solution, and then we could play around with another solution. I think I got a one that's all one space, so I'll just do it that way. I'm not going to try to fit in one variable, but depends on what they mean by extra memory. If this is not good enough, I mean, it's a solution that I still like the answer to, even if it's not good enough. So I'm gonna. That's why. I will start with 3. Was it not even the correct digit? Maybe say. Um, mm, yeah. Okay. Okay. Count 0 0. Say. Um, okay. Let's just use a different variable since we're already using more memory. I guess I don't even need this then. Okay, what am I doing? In norms. Oh, I guess I can't do it this way because I'm modifying it. I'm also modifying things in place. I don't, in theory, need to. It just makes the computation or the computation easy. Because you could do some more manipulative math to get digits of a number, but so I mean, we could talk about, yeah, actually, I mean, it still uses the same number of space. It just takes more computation for each one. So I don't think I worry about that per se. Oh, well, done is equal to force. Oops. Okay. Otherwise, sum is equal. Is sum a keyword? Okay, fine. Sum of digit equal to 0. Sum of digit plus nums x mod 3. Okay, and then nums x just divided by 3. Okay. And then at the end, answer. am I doing? Okay, so some of the digit is that stuff. So return some. Oh, and so this times the digit place, and then digit shift to the left in ternary, something like that. Maybe that's enough. Maybe I'm missing by a little bit, but should be okay. Oh, yeah, switching languages. Oh, oh, maybe okay, I shift this a little bit too early. Oh. Oh man, I would still say I hate these forms, even if I don't know what the. Can you do it without literally any extra space? I don't know, but I don't think sorting matters, so I'm just going to do a bunch of stuff. What do you mean by index? Sorry. Let's just try one number. Okay. And this stuff is just, like I don't need to modify this in place. I could do some shifting and more division as a result. Actually, I could probably just change this to divide by the digit place and then get the mod, but yeah, so that's not, I don't consider that using extra memory or even cheating. Yeah, okay, fine, let me just do it that way then. That's right-ish, maybe. Oh man, maybe it doesn't terminate because I changed something. Oh yeah, because this doesn't terminate. Number 6 is bigger than, was it digit? Oh, I see what you mean. I was reading it, but I didn't really parse what you meant. Yeah, to iterate, you need the index, so you can do it without literally any extra space. You're right. Okay, so this is still right. Okay, YOLO. Let's submit this. I thought it took way to these pointers. Oh man. Oh, there's negative numbers. I hate you. Well, I mean, we could fix it. It's not. It's not insurmountable, but why? uh, uh, maybe there's a more clever solution, but as a result of that, is there an XOR for like XOR E thing for? Because essentially we're just doing stuff with like a non-binary representation of numbers. But oh my god, how do I do this? I mean, it's not impossible. It's just it just makes things really complicated because mod is negative for some stuff, for example. I hate you and everything you stand for. Leetcode. Can you modify it easily? Because it takes them. Because both these could appear in the answer, so I don't. Man, this is destroying my mojo a bit. Also need to use the restroom again. I'm drinking too much of this milk tea. Might not be able to sleep, but Maybe we do have to do some invoice thing in that case, just to make it easier. But okay, maybe I just have to think about the negative numbers, which I don't think I do necessarily. Well, hi, Brain Society. I mean, it makes my ending condition also wrong. So, maybe, well, this I could just do this actually. But, oops. But, I mean, I think that's what for the first half of me trying to solve this, that's what I was trying to do by playing around the bits in binary. But you look at the ternary, which is kind of what I'm doing. Well, it is what I'm doing. Because everything appears 3 at a place, they cancel out no matter what the digit is, right? So that's how I'm trying to do it. Now I'm just trying to do the negative part, which is kind of annoying. Oops, what did I click on? Oh. Like, I think this is right for positive numbers, but now I have to figure out, like, modifying this for binary. I hate everything this promise. Also, why is this different than my other output? Did I do this weirdly? Oh, I changed this part of the code, which I guess is fair. Okay, I mean, it's fine. Maybe. I have to double check this as an ending condition, but two's complement stuff to replace XOR subtraction. Yeah. Sorry, my brain is like toasted on this farm now. Man. Yeah, I mean, yeah, I would say to post to Ed's point, I do. I mean, I like this. I like this solution to this problem, to be honest. Not gonna lie. That said, it's still not right, and I still have to figure it out. Why do they have negative numbers? And I actually think this is a cool, clever problem. Not for interviews. I don't think it is an interview problem, but it's a cool brain teaser. Otherwise, but now negative numbers got me thinking. How do I handle it? Well, I guess you could just count the number of negatives. Can you? Yeah, I guess you just count the number of negatives. If it's 7, then it's negative. If not, then and then you kind of essentially what you were saying, PB actions were saying with 2's complement, except for this is like 3's complement. So okay, okay. Well, now we're using more variables, but I don't know. Whatever. I think we're beyond that point. We're committed. I mean, there may be some other finagling I have to do, but it's fine. Actually, I just use that later. Negative count is not 0. Then we do essentially answer minus something like digits negative, something like that. Oh, just minus digit maybe digits times 3, but okay. Is that really right though? Let's just try a lot of negative numbers. I mean, I assume this is right for the other ones because this is not going to be true. I should have. Oh, there we go. That's kind of cool. But now I forgot my other number. I just want to keep it up. I should put it in a text path somewhere and figure it out. But yeah, great to have your PV action. But oh, well, I don't do any modification. I changed that actually. Um, I mean, I don't know what the algorithm is, but I actually changed it to not. I mean, I initially had to use modification, but if we look at the code now, there's no modification. Uh, for better or for worse. Okay, let's just do all negative numbers just in case. And also we have to probably test 0. Okay, let's just do that. Okay. Let's just do that in 0. Oops. Oh. Well, I mean, the negative is just, if you will, another bit. I don't know, but yeah, I don't know, but I would love to see that answer. Maybe this is the first time I put tradition and look at the discussion forum together, and we could talk about it afterwards. Let's YOLO this. Come on, okay. I mean, if it's a binary thing, we could talk about. I definitely want to. I mean, okay. If nothing else, we got an answer that works in, like we were saying, linear time times the number of ternary bits, or not bits, I guess they're not called, but ternary digits, which is log of 3 of, I don't know what the biggest number is, but log of 3 of 2 to the 64, or log base 3 of 2 to the 64, which is like, say, I don't know, 50 or something like that. I don't know. Someone with a calculator could do it, which is, okay, maybe I'll do it. Let me see. Log base 3 of 2 to the 64 is, okay, that did not tell me anything. I guess log of 2 to the 64 times, oh, whatever. It's less than 64, right? So times O of n. So that's linear for some definition of linear. And yeah, and we use constant number of extra space or one extra space. Yeah, oh yeah, 32. Sorry, I said 64 because I was thinking doubles, but you're right, 32 for integers for sure. Less than 32. Excuse me. I mean, you get a better precise number, but that's fine because it's base log 3. Because this is a log 3 operation. But and we use one extra space. I don't know if there's an extra memory one. Maybe we'll look at it together. Just for me to learn, because we spent a lot of time this farm for me not to. Like, it's gonna bother me tonight. How long do we spend on this farm? Wow, almost an hour. Dang. And this is just a medium. I don't know if this is like a known solution that people already know the answer to. Maybe that makes it easier, or maybe, I don't know. We'll see. I'll take a look in a second. But for me, I could clean up the code a little bit with but I think I use reasonable variable names in general here. Maybe I could take some stuff out of the while loop and like make this for a particular digit or something like that. But I think that's okay. Yeah, and yeah, I don't expect this to be I don't expect this to be an interview problem. If I'm wrong, I'm wrong. But well, now I know the answer, or one answer, and we'll look it up together. I know the answer too, maybe, but because this is apparently really slow. So yeah, it happens. I mean, it happens sometimes. Like we definitely, like, even me. Sometimes I will get into problems where I'm like, I should know this, but I'm having a brain fart or like blanking out on it. I don't feel like this is one of those problems. Well, maybe I see a solution that people talk about. Maybe I do. So hold my word to it. But yeah, it is a medium. I don't know. It's just one of those brain teaser things where, like, if you know the trick, it's probably like 10 lines of code, like now to is saying, but like, I don't know if it's useful at all or whatever. But yeah, I would never ask this on any real problem. It's a brain teaser. So I think like I said earlier, I think I've probably seen these kind of problems before. Similar, maybe not this one, clearly not this one, but it is what it is. I don't know. I think the difficulty is just decided by whomever wrote the problem and kind of, and these things are, especially for these brain teasers one, it's very hard to kind of quote unquote grade them correctly, because I feel like a lot of, like, it's very binary, right? Like, or bimodal, where like I feel like a lot of people know the trick because they've seen it before, and then they like solve it immediately, or like if you don't, then you may or may not eventually get it. So I don't know. Let me look at this guy's file. Man, this was supposed to be a short one. Eh, eh, eh. But yeah, it's very subjective. So I don't know. We'll see. I mean, postal path sum. Oh wait, do you mean single sum 3 or single numbers 3 or whatever? Or do you mean path sum 3? But yeah, the third version of this problem is also a medium. But I got that because I guess that one is more binary. I forget what the exact problem is. Oh yeah, there's two different numbers. But I got that because I was binary and I got stuck on the binary mode for a while. Maybe there's still a binary answer. So I'm going to look at it with you guys so we'll kind of see it. Uh, um, I don't know. I mean, end up, I end up doing it all of one. Yeah, I mean, well, I mean, with no extra memory, if you could do it all linear memory, then hash table is the obvious answer, right? So, yeah. I mean, minus that, I don't know. All right. Without further ado, this is the first time I've done this on stream where I'm just like dying to know the answer. So, let me go browse the discussion forum with y'all and then kind of see where it goes. Oh, there is a bitwise number. So, K minus 1, okay. For each bit in the counter. So I'm just going to read it really fast as I can. To start, look at one bit. Yeah. From what? M has M bits in binary form. Wow, this is a lot of reading. Oh man. It is midnight. This is the time for me to read this. But what is M? Each bit in the counter. Well, okay. I'll look at another one. Maybe that one's just so long. Challenge me, thanks. Wow. uh, there's some stuff about ternaries. Maybe not. Maybe without reading the description. Let's see. So it starts at 0. It looks through all the arrays. Oh no, just this array and the not 2s. And not 1s. Yeah, I mean, I think this is just. I mean, I guess I don't know the exact mechanics. I have to kind of sit down and really think about it. But I guess this is just keeping track, in a way, of like in a way individually, keeping track of base from like base 3 in each, like kind of what I did, except for like all together using very clever bitwise operations that I don't have the skill or thinking to. I mean, I don't know, I'm not going to read all this, but that's my guess. And yeah, I mean, I would have to really think about it on a day where it is not midnight, but a general way tends to. Hey, bits. Oh, I mean, I think this is. Oh, I see. I think this is fair. Um, I think this is what it is saying. Um, okay, that's actually. I think I get it now, kind of. Uh, I mean, not in a good way, but and you still need a lot of different states. But basically, it's still similar to what, uh, I mean, it's similar to our idea, except for that, like it's basically the general concept of these problems, and you have to design, like a circuit that makes this true. But essentially, you have to design your new, not an XOR operator, but like an operator that counts not bitwise, but in base m for whatever. In this case, it's base 3. But in base 3, you have to go from yeah, I mean, kind of what this is saying, right? Which is that let's say your current count for a digit, if you will, is 0, and you get something that has, I don't know, 1 or 2, and then you kind of keep on doing it repeatedly, and you kind of design an if, or like they call it bit circuit, but which is kind of, I guess it's related to kind of a logical operator circuit, and then kind of just do it that way, right? And it's kind of, actually, this is exactly what we do, except because we don't do it at the same time. Like, we don't do it at the same time. We just do it digit by digit. But if you do it, and this kind of crazy bitwise function, like if you do it that way, then you do it all the digits at the same time in parallel, kind of, because it essentially, or every digit moves from 0 to, or for some previous state, and then it goes to whatever it is, mod 3. Like, it adds that digit for the input number, and then mods it by, I think the idea is converting, let me just have a scratch pad, I guess. But basically the idea is similar to what we end up doing, but basically you have, an existing number for in a digit x, and then you add it to an incoming number with a digit, let's say y, and then you mod that by 3, and then you store it into the new x, and then you kind of represent that in an operator, generically, I guess, and because you do it in bitwise functions, then like it allows you to do it all at the same time, because you could think about each digit kind of counting it at the same time. But I think, to be honest, if that's the, I think the way I did it, I like it more. I don't know if I like it more, but it feels more intuitive to me, and it also scales to whatever base it is. You just change the 3 to n for whatever n it is, and it's, and it's fine. And you have to do the negative number, which actually, looking back, is kind of cool, even though I'm just frustrated at the time because I still was trying to figure it out. But yeah, I don't know. Is there? Does anyone have any questions? I don't know if I could explain that much better. But basically, what they do is, I guess the solutions in general just have, have like you can think of each digit as a state machine that have, yeah, like a state machine from, and you have n minus or m minus 1 states, where m is the base that you're doing. In this case, it's 3. So you have two. In this case, there are 3 states, where like the states are 0, 1, and 2, and then depend the incoming number or digit, you go to different states, right? And I think not this solution, but what was it? Oh yeah. And this actually visualizes for me. It's just that, like, this is a way to represent all those bit transitions and incoming and so forth. I mean they even call it incoming here, and kind of like keep track of it. And this is just, using A and B, but this just represents the number 3, or number 3 using 2 bits, right? So like, it's essentially what I was doing, except what they do it, because they do it with bits. They do it in parallel, which is definitely faster, and don't get me wrong, by an order of, I don't know, log 3 times or something like that, right? Or log 3 of the biggest number or something like that, or the number of digits in base n. But I don't feel bad about how I did it, even though it took me a while to get up to that. So people there is a binary, quote unquote, binary solution, but it's just a binary way of encoding a base and solution, right? So I think like logically it's the same. I want to say, even though they clearly like the way they did it is a clear better solution. Don't get me wrong, but like I don't feel ashamed doing it the way I did because essentially we're drawing the same state machine except for they do things more in parallel. Like like if you want to think of it differently, maybe I could have. Yeah, I don't know. I don't want to think about it too much more, to be honest. Spend like an hour and change on this one, but I think a little bit of a post-mortem because I don't think this should be an interview prompt, but is that could I have done this faster? I probably should have thought about. I mean, this is more mathematical, I think, so maybe it doesn't. For that reason, it's also not. Like I was still trying to think about something binary as a result, and I don't think there's an easy way to binary. Yeah, it does. Yeah, their solution also like is very specific to the fact that this is base three, right? So this is not a it's not a generic solution at all. Where mine is, I mean, you have to change some magic constants, but mine is a generic solution. I think for any base that fits an int or whatever, but that's always going to be an issue anyway. Um, but what was I going to say? But yeah, but now I totally forgot what I was going to say. Sorry. What was I saying? Uh, Oh yeah, yeah. Postmortem. Me, how to think? Yeah, I definitely should have thought about things in different base more. I think I was stuck on um, just thinking of pure binary, and there's. I mean, and it turns out looking at the solutions, I don't know if well, like there's no way to do it in pure binary. At least not no way to do it in binary. It's just no way to do it thinking about it in binary. I mean, their ways are just and like their ways were encoding, like I said, encoding the number n in binary in some way, and then kind of figure out the circuit from that, which is it's cool and pretty or whatever, but just and maybe something that I could bring up in an interview. But I think the way I did it is probably more intended. Uh, though in that case, it still took way too long, and I should have. But I think I mean, I think like y'all were with me for a little while. So I think I was stuck on the XOR thinking a little bit too much, and it turned out it wasn't a red herring. And inherent in that XOR is that that it is based off the fact that it's a binary um, representation or base two specifically, which is what binary means. But I want to say that in a way that is more general. Um, and and if you go back, like looking at this generic solution, and if you change the three to two, it actually still works, right? So it actually makes sense even in that case. Yeah. So what I was gonna say about that. So in that sense, XOR is just a very clean operation because even if the way they did it, you could rewrite XOR to like you know well, XOR you could write it by itself, but you could change it to like a series of if statements and not statements, right? Um, so in that sense, like an XOR just happens to be what comes up a lot in computer science and so forth. So it's an easier and cool way. But I think as a brain teaser, I really like this problem though, because it forces me to kind of think about why XOR worked for binary and stuff like that. And now I feel like I definitely learned a little bit about this type of problem. I don't know if it's how practical it is and stuff like that, but I definitely like it. It's an interview question, so maybe in that sense I would end up giving it a thumbs up, even though I kind of hate on it earlier. But that said, as an interview problem, probably still terrible, so I wouldn't recommend it. Uh, but I don't know. You need to know about it. I don't know what you can do about it. Sometimes you can't prepare for you know, everything, right? Like every brain teaser, you can't prepare for all of them. But I'm glad I did this one. But I would hope that that's not an interview question because I feel like you don't really learn about it much. And like if you've seen it before, it's great. And it did take me. I mean, I guess I got into it eventually, so maybe that could have been a little faster. Maybe if I did it interactively with an interviewer, they would poke me a little bit like now, don't think about it in XR, like, and I would spend less time. Maybe I could squeeze it in that way. And the coding is kind of relatively quick after that, but